Well, I'm going to just start with a little statement here, and then I'm going to explain it throughout the first part of my talk. And it goes like this. As the eternally inflating infinite multiverse fades into the world of fantasy, what's replacing it is a super intelligent, transcendent creator whose image cannot be suppressed. Let me try to explain that over the course of the next half hour, and then come back to you in a moment. Let me just start, though, before explaining my statement, by laying out a very curious phenomenon that's going on right now, if the Pew survey statistics are not skewed. While our young people are leaving the church in droves, scientists are not. Young scientists are actually becoming more and more theistic. In the 2014 Pew survey, you'll see the reason for this in a moment, but in the 2014 last Pew survey of the American Association for the Advancement of Science, 66% of young scientists, 35 and under, declared themselves to be either believers in God or in a higher transcendent power. Now that's very interesting. The other group, about 30%, declared themselves either to be agnostics or atheists, splitting it down the middle, 15%, 15%. Wow, 66% theistic or believers in a higher power, and the other, only about 15 to 16% on the atheistic side. Something is happening that you couldn't have possibly imagined even in the 1920s, just 100 years ago. Something like this would be an unimaginable statistic. Let's take a look at the overall statistic for scientists. So this would combine older scientists with younger scientists of all ages. And so if you look at that statistic, you can see that 51% of scientists declared themselves to be either believers in God or a higher transcendent power, while only 41% declared themselves to be agnostics or atheists. Split it down the middle again, it's about 21% agnostic, 20% atheist, right in that category. But 51% compared to 20%. But then now go back to that statistic for those young scientists. We're trending upwards, not down. Young scientists are actually, they're more open to God than ever before. And so this is a rather interesting thing. And, let's take a look at doctors. More than ever before, 76% of doctors declare themselves to be believers in God or a higher transcendent power. Well, I think it's only 12% consider themselves to be agnostic, and 11.6% or something atheistic. So something's happening out there in the world of science, and we get the impression sometimes that scientists are universally atheistic, and it doesn't seem to be the case, like I said, if the Pew statistics for the AAAS are not incorrect. What's even more interesting is people like, Richard Dawkins, who for years and years was a vehement atheist, suddenly comes and says, well, I'm agnostic, but I lean heavily toward atheism. That's a big move. And I just got to ask myself, well, why? Why is this happening? And I think the reason that it's happening is because there's evidence that's beginning to emerge. There's a mystery that cannot be suppressed. And I want to just give you a little insight into that, in the rest of this talk. Now, I just don't get too upset if you don't understand every term. I'm going to go through a lot of cosmology here to try and get my point across. But I think I just try to get the general gist of what's going on here because it's utterly fascinating. But let me use some technical terms and give me a little leeway here to confuse you. But stick with me. By the end of the talk, I hope I can make it as clear as possible that there's something, God is really being very, very crafty here. And he's slowly but surely lifting the veil. let me just go through some quick factoids about our universe that we know today. And then after those factoids, I'll get to the real meat of the talk. First of all, our universe, we believe that since the Big Bang, our universe is about 13.8 billion years old. As you will hear in two other talks, a Catholic priest, Father or Monsignor Georges Lemaitre, he is responsible in good part for this. If Mario Livio is right, he was the first one to publish what's called the Big Bang Theory today. He called it the theory of the cosmic atom or the cosmic egg. In either case, Lemaitre published it way back in 1927. And of course, since that time, the Big Bang Theory has been confirmed not only by the COBE satellites 1 and 2, the Planck satellite, the WMAP satellite, and the LIGO gravitational wave detector, et cetera, et cetera. It's been so verified so often. I think we're pretty good in saying that 13.8 billion years ago, plus or minus 100 million years, our universe exploded from something akin to a quantum gravitational position into, what we would call the general theory of relativity universe that has been expanding ever since then, and today is expanding at an ever-accelerating rate. I'll talk about that in dark energy in just a moment. But that's an important fact because for many, many years, of course, Aristotle, and as you know, Aquinas, they just thought, well, from physics, you cannot deduce a beginning, so you should just assume that the universe is infinite from physics, but from the vantage point of faith, we know that it has a beginning. Now, today, things are changing, as Lemaitre said. We're getting this insight that beginning may be, in fact, a necessity, and that's going to be part of my argument coming up in a moment. Let me give you a few other factoids, though, really quickly. The first one is that we've probably got about 5% visible matter in our universe. So the universe has parameters out there, but we've got about 5% visible matter. We've also got about 25% what's called dark matter. Dark matter doesn't radiate any light, right? It doesn't reflect any light. It just sort of absorbs things, but there's no emanation of light radiation, anything coming from it. And so, yet it does have an attractive quality for the gravitational field and is very important for holding our galaxies together. So you don't want to get too much of an absence of dark matter. You need the visible matter plus the dark matter to hold the galaxies together. But then you've got another force out there called dark energy, and it's just the opposite of dark matter. Dark energy is repelling things, right? So dark energy is almost like think of it as like a field attached to our space-time field, which is just pulling the universe apart. And that's why galaxies are expanding, away from each other in our universe, so much so that the further you get, the further out a galaxy is, the greater its velocity moving away from us, its so-called recessional velocity. So we have these statistics out there. And by the way, these things are all subject to change. What we're talking about in this talk and throughout the days, except for, of course, philosophical talks or more metaphysical talks, but in the scientific realm, remember, scientific facts are changeable because they await future discovery. Some future discovery could be made. It could change things. We're getting more and more, certain about certain kinds of facts these days, and the evidence for those facts is compiling more and more. But nevertheless, just remember this. Scientists don't know what they don't know until they have discovered it from our observational data. So we've always got to await new discoveries, and we cannot say that anything scientific is absolute certitude, but you can have some good probabilistic certitude. But that caveat having been stated, let me just continue. We probably have in our universe, in terms of visible matter, we have probably about 10 to the 80th baryons. The baryon's like a heavy particle, a sort of a neutron, proton, worth of mass in the universe, which comes to about 10 to the 55 kilograms of mass in our universe. So we've got some parameters out there in the universe. We have 4 forces in our universe. We have the gravitational force. We'll talk about that a little bit in a moment. We have also got the strong nuclear force. We've got the weak force, and we've got the electromagnetic force, which of course is composed of three constants that we'll talk about later. But these four forces are producing most of the physical reactions that we see out there in our universe. Enough factoids for the moment. What I want to get into now is how the universe seems to be perfectly constructed for life. This is the question that needs to be answered. And that's why I started this whole talk with the eternally inflating infinite multiverse. Why is this thing going to be so popular? Well, if you have an eternally inflating infinite multiverse, anything could happen at any time. And of course, all the coincidences, all the what we call the cosmic coincidences, all the anthropic coincidences for life that I'll be talking about in just a moment, all those things can be explained because you've got an infinite amount of time and an infinite number of bubble universes in which this can occur. And so we've got to show, is that really a tenable theory anymore, the infinite multiverse that's been out there for an eternity? And of course, I'm going to say no, on the basis of some really good physical data from very fine physicists like Stephen Hawking, etc. But let's get to the coincidences first. Is the universe fine-tuned for life? Oh, it is exceedingly fine-tuned for life. Let me just give you a few examples. The low entropy of our universe, and of course, many of you have heard of the Penrose number. I just met a fine, I think it was a Hungarian physicist who was, talking to me about it. And you can see pretty clearly here that low entropy is needed for life to develop in our universe. What low entropy means is high order. What high order means is that physical systems can actually have what we'll call thermodynamic change. So you can have, large and small flows of matter and energy which cause changes within a system. If you can't get any change within a system, if you can get no flows of matter and energy, if you have low order in your universe, if you have high entropy in your universe, you're going to have a dead universe really quickly. And it's very hard for life to develop, let alone life to evolve in a dead universe. Now, our universe, get this, our universe has exceedingly low entropy, exceedingly high order, it allows for all kinds of change to occur, all kinds of net flows of matter and energy that cause change. Now, what are the odds of this nice low entropy, high order universe just popping into existence by pure chance at the Big Bang? Well, it's a double exponent, so get ready. It's 10. Then the next exponent is another 10, raised to the 123 to 1 against. That's a 10, and if you just were to write out the exponent, it'd have to have a 1 with 123 zeros after it in the exponent. That would be a trillion, 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 trillion in the exponent. If you tried to write that number out, our whole solar system could not fit that number if every one of those zeros was 10-point type. It's the same odds as a monkey typing the entire corpus of Shakespeare by random tapping of the keys in a single try. Highly, highly unusual. Let's just say virtually impossible. Yet it happened. That's the low entropy of our universe. Roger Penrose calculated it way back in 1992, and nothing has changed since then. Physicists continue to be flummoxed by that number. There's got to be an explanation. And without that low entropy, there's not going to be much happening in our organic universe. certainly not the development of life. Let's take a look at another number that's really important. It's called the cosmological constant. The cosmological constant not only controls whether the universe will expand or collapse, but the precise rate at which it will expand or collapse. Now, in this case, we need an expanding universe, but we need the Goldilocks deal here. We need our universe to expand at just the right rate. Now, of course, in order to do that, you're going to have to get your dark energy and your dark matter, and you're going to have to get the equations that combine these things together, and all the contributions from the attraction side, all the contributions from the repulsion side, they all got to be matched up. And as Steven Weinberg said, who was not necessarily a friend of religion, he put it out as solidly as anyone could put it out there. The cosmological constant needed for the precise Goldilocks expansion, needed for our universe to develop and not go into a black hole and collapse, or not just expand too fast so that everything becomes dispersed matter. You don't have any protons or neutrons, or you don't have any hydrogen, or you don't have any element heavier than hydrogen. If you're going to get that cosmological constant just right, you're going to have to fine-tune it to 1 part in 10 to the 120th. Now, just think about that for a moment. That's a billion, trillion, trillion, trillion. 1 little part in a billion, trillion, 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 and we're dead. Higher or lower, and we're dead. That's all there is to it. But here's the deal. I mean, just think of this. Think of the entire earth covered 10 feet down with sand. And there's only one little grain of sand in that huge lot of sand that will allow the universe to develop and have the cosmological constant necessary to give rise to life. That's really unusual. That grain of sand should have been selected on the first try. Very, very unusual. Let's go to just a few other constants. See, you're going to get the picture. I don't have to keep listing them. There's a good number of them. But just right now, if you just take a look at the weak force constant, right? Remember those 4 forces I talked about? You have the weak force constant, and you also have the gravitational constant. Each one of these forces, the weak force has the weak force constant, the gravitational force has the gravitational force constant, the strong nuclear force has the strong force constant, and the electromagnetic force has 3 constants associated with it: the mass of the electron, the mass of the proton, and the electromagnetic charge. Now, the main thing to remember is these constants are invariant in the universe, and they have to be exactly what they are. You can't have just even little deviations higher or lower, and if you get too far of a deviation higher or lower in that window, you are simply not going to get a universe that will sustain life. So take the weak force constant and the gravitational force constant in relationship to the cosmological constant. The cosmological constant is really governing this thing again. But if the weak force constant, gravitational force constant, in that relationship, that ratio was off by 1 part in 10 to the 50th, well, hate to say it, but every single star in our universe would have been, if it was 1 part in 10 to the 50th higher, our universe would have been continuously exploding in its expansion, which, by the way, would have been exceedingly bad for life forms. Alternatively, if it had been off in 1 part in 10 to the 50th lower, the entire universe would have collapsed into a black hole after a second or two. Exceedingly bad for life forms, as everything in the physical universe is being collapsed into 10 to the minus 33 centimeters, squished to death. You mean we avoided complete travesty by 1 part in 10 to the 50th and those 2 constants, higher or lower, from the values they just happened to have at the Big Bang? I mean, this stuff is like monkeys typing Shakespeare, monkeys typing Hamlet, monkeys typing Macbeth. This is ridiculous. Then just keep going. I mean, the electromagnetic charge, right? You've got those three, the electromagnetic force. You've got three constants in balance in order to avoid what's called convective instability in stars. If you have those three constants off by 1 part in 10 to the 39th, higher than they are actually, then of course we'd have convective instability in every star. Every star in our universe would be a blue giant. This big, huge, hulking, burning hot, searing flames in every single star in our galaxies, burning everything. Bad for life form, very bad for life form. Alternatively, if you go off 1 part in 10 to the 39th lower, what will happen? Every star in our universe and galaxies will be red dwarfs. And of course, a red dwarf star is so cold, not even a Hawaiian could get a tan from this. So it'd be bad for life form. We've got to get some heat. Pardon? 30? Okay, I got to move on quickly here, more quickly, I perceive. But anyway, you get the point. I'll just simply say if you had a strong nuclear force constant, it was 2% higher, you'd have no hydrogen in our universe. If it were 2% lower than it actually is at the Big Bang, you'd have no element heavier than hydrogen in our universe. You get the picture. When we put all of these constants together with the really big one, low entropy in our universe, 10 raised to 10 raised to 123, and you put it together with the constants for the fine-tuning of our cosmological constant, etc., probably you could fairly say that our universe is about fine-tuned to about 1 part in 10 raised to the 10 raised to the 125th to 1. That's what we really need to have in order to get life forms to develop and evolve in our universe. Now, that's a really big number. That's not just the monkey typing Shakespeare. That's the monkey typing Shakespeare, all of Milton, name another 10, 15 literary geniuses by random tapping of the keys perfectly in a single try. Our universe is so unusual. It is so out of the question, enormously improbable. And it's our big, organic universe that's so filled and lush for life is so improbable, so unusual. As we'll see in a moment, it's almost impossible to explain how this could have happened by pure chance. Now, because of this, physicists are, they are honest people. They're going to try and answer this question. How could this happen? And so, of course, the usual theory that we have from Christianity is pretty clear, right? And that is, well, there's a really highly intelligent, transcendent creator who just set the constants as they are, who gave us all that low entropy and high order at the Big Bang, set all the constants to be the exact right things they need to have for the amount of matter and energy that's in the universe. And that's that. We can explain it that way. And as I'll say in a moment, that's I'm going to say it's the most reasonable and responsible way to describe it. But other physicists would say, no, you have to, there's naturalistic explanations of this phenomenon. Now, one of them was, of course, the oscillating universe, right? The bouncing universe, expanding and contracting and expanding and contracting. But nobody believes anymore that the bouncing universe can do this because we probably don't have a bouncing universe. And even if we did have a bouncing universe, the low entropy as we go back further and further and further in time. So let's suppose, you're going back further. The entropy has to get lower and lower and lower. And that means you're going to have, higher and higher order as you go further and further back in time. Even the atheist Sean Carroll said, the bouncing universe, if it were eternal, the bouncing universe would have infinite fine tuning, which is 100%, 100% unpredictable, 0% chance of happening. It would be infinite fine tuning for no apparent reason. So even the atheists rule out the oscillating universe. The amount of dark energy rules out an oscillating universe. That's not going to be the explanation. So physicists turn to another explanation. I know this seems like a long build-up, but you'll see the relevance in just a moment. But the main thing is they started turning to string theory, and they get some really elegant universes. You get higher dimensional space universes in string theory, where you can have, two brains, colliding in a four-dimensional space-time cluster there, and that might pop out other new universes, etc. But then these guys, Borda-Vilenkin and Guth, came along, and Arvind Borda from University of California, Santa Barbara, Alexander Vilenkin, who is the director of cosmology at Tufts University in Boston, and Alan Guth, who had the high chair of cosmology at MIT. They came along, and they basically put together a proof in 2003, which not only showed that every inflationary multiverse would have to have a beginning, but also every string universe in the higher dimensional space of string theory would have to have a beginning, and that every single one of the nucleating models in string theory of bubble universes coming out would have to have a beginning. And arg, if all those things have a beginning, how are they going to explain 10 raised to the 10 raised to the 1/25th to 1 odds happening? It's going to be a hard haul. So in 2006, a new theory was proposed, one that seemed to be the ideal solution, and that was the so-called fractal multiverse. Because with sort of an infinite fractal in a mosaic of bubble universe. A bubble universe is just a universe like ours amidst billions and billions and billions of other bubble universes in a big multiverse. But this multiverse wouldn't be a regular inflationary multiverse. It'd be a fractal multiverse. And therefore you could just have this, huge exponential growth of bubble universes that's going on. And supposedly it would be without limit. It could be, eternally, growing, and it wouldn't even have to grow from a beginning. You could get out of a whole lot of stuff, and that seemed to be the solution because, as Alan Guth put it, right, if you have an inflationary and a fractal multiverse rather than an inflationary one, then you could literally have an infinite number of bubble universes that, one of which is ours, but an infinity of others not like ours. And you could have it last for an eternity, for an infinite amount of time. Well, as Guth put it, in an infinite amount of time with an infinite number of universes, everything is possible. And physicists said, well, that's that. We finally got rid of that whole thing of needing a transcendent creator. But then a few things started happening. God, it's so crafty. And of course, what happens is, there's a group of physicists there at Berkeley and a couple of other physicists at MIT, and they said, well, that won't work. Because if you have an infinite number of bubble universes that have been around for an infinite amount of time, why, you'd have an infinite number of thermal vacuums. Now, a thermal vacuum really is almost next to nothing. But the odds of a universe, what we'll call one of these thermal vacuums, giving rise to a Boltzmann brain, that is to say, a brain suddenly fluctuating into existence in a thermal vacuum, right? So you've got this brain and it pops into existence fully loaded with all the images and memories of being in a carbon-based universe like ours and seeing other people out there in the audience that are just like the ones I think I'm seeing. Well, of course, I'm not seeing anything, but the point is pretty clear. But nevertheless, that brain popping into a thermal vacuum, and of course there's an infinite number of thermal vacuums and an infinite number of bubble universes. Well, if that's the case, what's the odds of a Boltzmann brain fluctuating into existence fully loaded with those memories? 10 raised to the 10 raised to the 90. Well, the odds against our carbon-based universe are 10 raised to the 10 raised to the 125th. If you divide 10 to the 10 to the 125th by 10 to the 10 to the 90th, it's still pretty close to 10 to the 10 to the 125th. 10 to the 10 to 90, it doesn't affect it at all. As Penrose says in his book, just try it. Go ahead. Calculate it. It's still close to 10 to the 10 to the 125th. Well, what does that mean, you guys? It means this: we're all Boltzmann brains. We don't live in a carbon-based universe like this. We are a Boltzmann brain that has fluctuated into existence, fully loaded with memories of living in a carbon-based universe, and we think that's what's happening to us. But in point of fact, the odds of having a carbon-based universe like ours are so far out of reach compared to the number of Boltzmann brains in that infinite multiverse. Every one of us is a Boltzmann brain. Now, Sean Carroll, who's a good atheist out there, he really got upset at this. He said, well, there are some ways of working our way around the thermal fluctuations. And then this guy, Don Page at the University of Calgary, comes out and he goes, well, actually, you could also have the same phenomena happening in quantum vacuums. And so, of course, at the end of the day, he called those brief brains. Either we're a Boltzmann brain or a brief brain. If there's an infinite multiverse, and it's the infinite multiverse is eternal, and anything can happen, and there's an infinite number of thermal and quantum vacuums in these universes, we're all Boltzmann brains. It's a flat-out zero. We're in an organic universe. It's all an illusion. But if you believe that, I've got a bridge to sell you. The point is pretty clear. No one believes they're a Boltzmann brain. They believe, and we begin our whole scientific discovery and expedition believing we're in this carbon-based, luscious, spacious universe, so against the odds. I don't think so. But that was the first thing. The second thing that happens to the infinite, eternally inflating multiverse is a guy who basically has, he's kind of on the, just kidding, he's not on the periphery at all. His name is Stephen Hawking. And he has a partner named Thomas Hertog. And he publishes a paper a few months before he died in the Journal of High Energy Physics called A Smooth Exit from Eternal Inflation. And in this paper, by the way, you can get a great little analysis of this in Cambridge University's website. Just go to an article called Taming the Multiverse. Taming the Multiverse, and you can get all these quotes from Hawking and Hertog. But what's their basic point? Their basic point, and this is important, is that if you have an infinite multiverse, which would be a fractal multiverse, then we could not, in our universe, maintain the difference between classical physics and quantum physics. But we do have a difference between classical and quantum physics. There is a differentiation between the two kinds of physics in our universe, and Hawking said that rules out the possibility of our being. By the way, there's no remnant of our having, as it were, detached or come from a fractal multiverse anyway. And so, of course, once he says this, Hawking doesn't stop there. Hawking goes on to say, not only would that mean that we came from a multiverse that had a beginning, a boundary in past time. He states it out explicitly. He says, the multiverse from which we came would have to have a boundary in past time, i.e. a beginning. And more than a boundary in past time, says Hawking, it couldn't have an infinite number of bubble universes. In fact, it couldn't even have a large number of bubble universes. The fact is, if Hawking and Hertog are correct, then basically it has a very small number of bubble universes. Now, why is that so important? Go back to 10 raised to the 10 raised to 125th to 1. Just go back to that number. If you had to have that number of bubble universes, that would be an extraordinary number of bubble universes. But what Hawking and Hertog are saying is, we're not even going to come close. The multiverse, if indeed there was one. Hawking says, well, we're not down to one universe yet. But what we are saying is that the multiverse that generated us has a very small number of bubble universes. then the multiverse is, if Hawking and Hertog are correct, then the number of bubble universes is just simply not going to happen. Okay. So the key thing then is, if that's the case, and by the way, there's several other physicists who have contributed to this. I'm not going to go into it now with my 15 whole minutes left. But the thing that's really crucial to see is this, that first of all, if you have a multiverse at all, and it's not necessary, right? It's hypothetical, and that bubble universe has a beginning, and that multiverse, has a beginning, and the number of bubble universes are small in number and very much like our own, then the cosmological constant, then the low entropy of our universe, and all the other constants I talked about are not going to be explained by it. It just seems right now, between Boltzmann brains, Brief brains, Stephen Hawking, Thomas Hertog, and a variety of other physicists who are out there writing about this. In fact, one physicist was very candid. He just said, eternal inflation violently goes against experimental data. So that's a kind of a dramatic point that he's making. What's my point, though, that I think is so important? The point is, it looks like the infinite multiverse, it looks like eternal inflation is simply fading away into fantasy land. And what's beginning to emerge is this incredibly difficult to explain, perfectly designed for life universe that has every one of these constants refined to just one part in, 10 to the 50th, 10 to the 39th, one part in 10 to the 120th, indeed, one part in 10 raised to the 10 raised to the 123 to 1. Totally amazing. What it means is we've got one explanation left. Tegmark, I go into this later, but he talks about, level 4 multiverses, but it's big category error. He's confusing ideas with physical reality and individuation. That's another problem. But if you take all that aside, the most reasonable and responsible explanation is that we have a creator. A highly intelligent creator. And of course, let me tell you what Alexander Vilenkin said before the infinite multiverse came into being. Alexander Vilenkin, he's the V in the BVG proof, the Board of Vilenkin and Guth proof. Vilenkin said in 2006, it is said that a reasonable argument, that a good argument will convince a reasonable person, and that a proof will convince even an unreasonable one. Well, now that the proof is in place, proof is, right, the BVG proof plus entropy, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They must confront the problem of a beginning. Now, if you look at that for just a second, that was in 2006. Then you got the infinite multiverse. Now we're right back at good old Vilenkin. Now we're right back with the infinite multiverse being challenged on every angle. We're right back to where we started. And if we started with that statement about needing a beginning, now we even have a worse problem to contend with. Because of Stephen Hawking, it looks like the number of bubble universes are very limited and that they are very much like our own. They're not restarts with wholly different constants. They're really kind of little ancestors of ours. They're kind of related to our universe. And that means, in my view, that at the current time, science is pointing to a creator, a transcendent creator, who's highly, highly intelligent. I think this has been kind of a waiting discovery for many, many years. The point that I would want to make, too, in the same process is, I think we're getting some concomitant evidence, too, from near-death experiences for a soul. And I'm just going to shift topics on you. But right now, I think I'm going to conclude this cosmology part with just that Robert Jastrow's statement way back in 1978, which is now just as applicable as it was in 78 with the contributions of Hawking and Hertog and Boltzmann brains, brief brains, etc. Here's how he phrased it. And I'm paraphrasing it with a little more drama here. Scientists unshackled themselves from the domain of superstition, and they climbed and ascended the mountains of knowledge with a strict empirical mathematical methodology, got to the final precipice, pulled themselves over, and found a band of theologians there awaiting them for centuries. I think that it still applies today as much as it did before. Thank you. Now, just one quick thought about, the soul, because I do think our kids are closet materialists, and I'm going to give you just a few materials, shamelessly at the end here. But I do think we need to look at the soul more seriously, and I think this has been coming out, again, God's craftiness, very shrewd, he wants to keep us free. He kind of leads us along. He's not going to force us. He's pulling us in, but that's the way it is. But now we start looking at this data on near-death experiences. We're talking about some really first-class studies that have been done by a series of really first-ranked medical journals that have published them, all peer-reviewed journals. Samuel Parnia made his 2014 study with 2,060 patients. I'm sure Dr. Pim van Lommel, a lot of you are familiar with that, published in his study, in the international study in the Lancet. Then, of course, you had the Kenneth Ring study of the blind people, which showed that 81% of blind people saw when they were having a near-death experience. Let me explain that notion of near-death experience to you. It just basically means that a few seconds after your heart stops and no oxygen's going to the brain, and you start to register a flat EEG, that's no electrical voltage going across the surface of the cerebral cortex, no voltage in the frontal cortex, and it's starting to go all the way down to the lower brain. And in the lower brain, you've got a few sputterings of neurons, but not much more. And then during that time, when cognitive activity should be downright impossible, certainly through the cerebral and frontal cortices, right? That very moment, a soul seems to leave the body. It can see, it can hear, it retains all of its memories, it can move, it is memorizing what's going on around it, reporting things, later that it experienced. And of course, it defies gravity, right? Can move up and down, can go through walls. Many times, blind patients that we have on our Armando's website, right? They just go right through the hospital walls. And when they go through the hospital walls, they can describe very perfectly. These are blind people, 16 years old, never saw a single, visual image in his life, right? He sees this train going by with a big arrow on a sign on the rear of the train pointing to the right, going into a grove of trees. And first time you've ever seen snow and grooves in the snow from the train tracks. He's describing this whole thing. And indeed, a train did pass by the hospital at the very same time. How would he know it? His physical body's in the operating room. Yet he's describing this activity going on outside the hospital with perfect lucidity and perfect timing. And you say, oh yeah, there's a physicalist explanation for this. A physicalist explanation. How could that kid be hallucinating? He's never had a visual image in his life to hallucinate in his physical brain. This is really hard to explain. So a lot of people, like this guy, Mario Beauregard, a neurophysicist there at the University of Arizona, begins to, answer to the physicalist explanations. The Grayson studies over at the University of Virginia Medical School are really excellent in the same regard. But the big, point that just got made in 2022 in the New York Academy of Sciences, there was a huge peer-reviewed, they reviewed all the peer-reviewed studies, on near-death experiences. And the New York Academy of Sciences, this is under the leadership of Sam Parnia, but 26 other scientists basically declared that they thought that it was very, very probable that your consciousness will survive the death of your physical body. Number two, that you will have a sense when you are leaving your physical body of a vast sense of consciousness, right, as you are leaving your physical body. Clarity in sight, et cetera, et cetera. Number three, that when you leave your physical body, you will have the sense of going to a destination here in this earth, maybe somewhere in the operating room, maybe somewhere outside the hospital, maybe somewhere outside the, right? So, as this one lady said, I was just hovering around outside the hospital there, and I saw a tennis shoe with a worn left toe there with a shoelace sticking under the heel of that left toe and so forth. And so they're saying, yeah, there's going to be some form of destination that you're going to feel yourself going to, or you could go to another world where you might encounter some deceased relatives or friends, or where you might indeed encounter a loving white light. Furthermore, you will have a tremendous sense, if you have a good near-death experience, you'll have a tremendous sense of being at home. You will also have a high probability of having a life review that is very detailed, but it will happen very quickly, but it will seem detailed. It'll seem like, covering your life in a very detailed way. And finally, a return back to your body. Now, I don't want to say anything, but if the New York Academy of Sciences is going to go out on a limb and say, this really just isn't a bunch of hooey. There's some really, really good studies out there with really good timing indicators that really have good statistical basis, are longitudinally done by over 10 people in the study group who are medically qualified to make these assessments. And you have study after study done, and we cannot, with our good neurophysicists, find an explanation for this that is, physicalist in nature, where the brain could actually produce such a hallucination through anoxia, stimulation of the temporal lobe, stimulation of other kinds of lobes in the brain, et cetera, et cetera. It just simply doesn't happen. It defies any kind of an explanation, yet we have thousands of veridically justified cases of it. Hell, maybe your consciousness really will survive your bodily death. And we might say, at least that's a tentative approach to the fact that you have a transphysical soul. And that transphysical soul would probably have to be created by a transphysical cause, because it certainly couldn't be created out of a physical evolutionary process. So the Catholic Church, once again in its prescription that if you believe in evolution, you just can't deny that God created an individual soul for everybody. Well, now there seems to be real evidence for that transphysical soul, and the evidence keeps coming out. There's going to be another big study done of peer-reviewed literature on this, and as we'll see, I'm pretty sure it's going to validate the very same conclusions of the New York Academy of Sciences. So there you have it. I think our cosmos was truly created by a very intelligent God, and he's gradually revealing himself, unveiling himself to us. And I think we do have a soul which will survive our bodily death and very likely encounter the God who created that universe. Thanks so very, very much.